Good morning, grade 11 students. This is our week number 7 lesson for today, Geologic Processes and Hazards. In this lesson, we will describe the geologic processes and hazards happening in the community. Geologic processes like earthquake, volcanic eruption, and landslides lead to different hazards. But ano nga ba yung tinatawag natin na hazards? A hazard refers to a potentially damaging physical event, phenomenon, or human activity that may cause the loss of life or injury, property damage, social and economic disruption, or environmental degradation. Hazards are extreme natural events with a certain degree of probability of having adverse consequences. Now let's talk about geologic processes and hazards. Geology is the study of the earth and its history. It involves studying the materials that make up the earth, the features and structures found on earth, as well as the processes that act upon them. It also deals with the study of the history of all life living on the earth now. But the question is, how do geological processes occur? We all know that Earth is a dynamic planet. Geological processes occur to us constantly. Some of them are go on invisible for us, but some of the geological processes make a great damage. Now let's have the term geological processes. It describes the natural forces that shape the physical makeup of a planet. Plate tectonics, erosion, chemical weathering, and sedimentation are all examples of forces that significantly affect the Earth's surface studied by geologists and earth scientists to improve their understanding of the planet history. Some of the questions that we need to know in these lessons are as follows. The first question is, how is the hazard defined? The second is, where do we expect earthquakes? When do we expect earthquakes? And what will happen in those earthquakes? Now, let us focus on natural hazards. Natural hazards are categorized into four. We have the geological, hydrometeorological, biological, and technological. Kapag sinabi natin geological, it is associated with earthquakes, volcanic eruptions, and landslides. Kapag naman hydrometeorological, ito yung mga cyclones, typhoons, and hurricanes, tornadoes, floods, thunderstorms, and coastal storm surges. Ano naman kapag biological? Those are outbreaks of epidemics, diseases, insects, and other animal plagues and infestations. Kapag technological, ito yung mga famine, degradation, pollution, industrial, and transport accidents. Okay, doon sa apat na natural hazards, magpo-focus tayo sa geological hazards. Ano nga ba yung nasa geological hazards? It is associated with earthquakes, volcanic eruptions, and landslides. So what are those hazards associated with earthquakes? So we have ground shaking, liquefaction, landslides, tsunami, and surface faulting. Ano bang meron sa lahat ng ito? Tandaan, areas that are at risk to earthquakes may also experience these hazards. Before we start, let us define first what is earthquake. An earthquake is a trembling or shaking of the ground caused by the sudden release of energy stored in the rocks beneath the Earth's surface. If you could still remember, in tectonic forces within the Earth produce stresses on rocks that eventually exceed their elastic limits, resulting in brittle failure. energy is released during earthquakes in the form of seismic waves. It is released from a position along a break between two rock masses, or what we call the fault. In elastic rebound theory, earthquakes are a sudden release of strain progressively stored in rocks that bend until they finally break and move along a fault. Now let's have earthquakes and plate tectonics. Earthquakes are caused by plate interactions along plate tectonic boundaries, or tectonic plate boundaries. Plate boundaries are identified and defined by earthquakes. Earthquakes occur at each of the three types of plate boundaries. We already talked about this when we have our plate boundary lesson, the divergent, transform, and convergent. At divergent boundaries, tensional forces produce shallow focus quakes on normal faults, while at the transform boundaries, shear forces produce shallow focus quakes along strike-slip faults, while at convergent boundaries, compressional forces produce shallow to deep focus quakes along reverse faults.
Earthquakes. An unexpected movement of the Earth's surface is called an earthquake. When two parts of the Earth's surface move suddenly in relation to each other along a fault line due to tectonic forces, an earthquake occurs. A tremendous amount of energy is released in the form of tremors and vibrations. Such earthquakes are called tectonic earthquakes. The point of origin of an earthquake is called the focus, while the point directly above it on the surface of the Earth is called the epicenter. Owing to the strong vibrations around the point of origin, the degree of destruction is greater around the epicenter. The branch of knowledge that deals with the study of earthquakes is called seismology, and the experts who study seismic waves are called seismologists. There are three types of seismic waves that spread in all directions from the focus. They are the P, S, and L waves. The compressional waves are the first to reach the earthquake recording station as they travel 1.7 times faster than the shear waves and are therefore called primary or P waves, while the shear waves are called secondary or S waves. The primary waves cause the particles of rock to vibrate forwards and backwards in the direction of the waves. Secondary waves, on the other hand, cause the particles to oscillate at right angles to the direction of the waves. When P and S reach the surface of the Earth, they get converted into L long waves that travel along the surface, vibrating horizontally at right angles to the direction of the waves, called love waves or Rayleigh waves, as they also travel like sea waves. The most violent shocks and subsequent destruction is caused by the L waves. The instrument used to detect and record seismic waves is called a seismograph. The recorded material appears like a graph and is called a seismogram. Based on the depth of their foci, earthquakes are classified into three types. They are deep focus earthquakes that occur at depths exceeding 300 kilometers the reasons for which have not yet been identified. Intermediate focus earthquakes with depths of foci ranging between 55 and 300 kilometers. Shallow focus earthquakes with depths lesser than 55 kilometers. To measure the magnitude of the earthquakes, a Richter scale is used. The point scale is arranged in such a way that each of the units on the scale is equivalent to 30 times the energy released by the previous unit. While a magnitude of 2 is seldom felt, a magnitude of 7 indicates the lower limit of an earthquake that has a devastating effect over a large area.
Let's have the body waves. Body waves have two types. We have the primary or P waves and the secondary or the S waves. It travels through the earth. The two types have different motion. The first one, we have the primary or P waves. Particle motion is parallel to wave direction. It travels fastest or it arrives first. And it travels through solid or liquid or fluid. While the secondary waves or S waves, the particle motion is perpendicular to wave direction and it travels slightly slower and only travels through solid as explained on the video that you have watched. Since we're done with the body waves, now let's focus on the surface waves. It is the slowest type of seismic waves produced by earthquakes. Lava waves is one of the type of surface waves. It is side-to-side motion of the ground surface. It cannot travel through fluids. The second type of surface wave is what we call the Rayleigh waves. The ground moves in an elliptical path opposite the direction of wave motion. It is extremely destructive to buildings. Okay, kanina nabanggit doon sa video na ating napanood how they measure earthquakes. Paano nga ba natin na-measure ang earthquakes? So the first one is what we call the seismometers. It is used to measure the seismic waves only. The second one is the seismographs or seismographs. It is recording device used to produce permanent record of the motion detected by the seismometers. And the third one is what we call the seismograms. It is the permanent paper or digital records of the earthquake vibrations and used to measure the earthquake strengths. Naiintindihan po yung pagkakaiba ng tatlo, the seismometers, seismographs, and the seismograms.
Magnitude and intensity are both related to the size of an earthquake, but they each measure different aspects. Magnitude, which measures the energy released at the source of the earthquake rupture and is calculated using measurements from seismic instruments, is one single value. Seismic intensity, which is the measurement of the strength of shaking at a specific location, determined from effects on people, human structures, and the natural environment, produces a range of shaking intensities in different locations. Thus, unlike earthquake magnitude, which is the same for all locations, the seismic intensity you feel depends on where you are. Intensity is mostly controlled by three factors: magnitude, how big the earthquake was; distance from the hypocenter, intensity varies from place to place; and the local rock and soil conditions. Let's compare magnitude and intensity by using a light bulb as an analogy. The light bulb represents the location within the Earth called the hypocenter, where the earthquake begins. The magnitude or size of an earthquake is like the wattage of a light bulb. Just as the wattage represents the amount of power of the light bulb, the magnitude is related to the total amount of energy released by the earthquake's source. The intensity, or shaking level, is like the amount of light from a light bulb at any spot in a room. A small light bulb in one area of a room will make that area bright with high-intensity light, but it will leave the distant areas of the room dim with low-intensity light. So, A given earthquake has only one magnitude, but will produce different intensities of ground shaking, as shown on the USGS Did You Feel It intensity maps.
Earthquake size measured in two ways. We have intensity and magnitude. Intensity is a measure of the effects of an earthquake produces on both structures and people. We use modified Mercalli scale in measuring the intensity of an earthquake. Magnitude is a measure of the amount of energy released by an earthquake. It is measured by Richter scale, while moment magnitude is more objective measure of energy released by a major earthquake. Ano nga ba ang pagkakaiba ng magnitude at intensity ng lindol? Kapag may naganap na lindol, kasamang nababanggit sa mga balita ang magnitude at intensity ng lindol. Alamin natin kung anong pagkakaiba ng dalawa. Pag sinabi nating magnitude, ito ay ang tawag sa enerhiya na nagpagalaw sa lupa o sa epicenter, ang lugar kung saan nagmula ang lindol. Kapag naman, intensity, ito ay ang lakas ng paggalaw ng lupa sa isang partikular na lugar na apektado ng lindol. Ang intensity ay binabase sa pakiramdam ng tao at epekto nito sa paligid. Habang papalayo ang lugar mula sa epicenter, papahina ng papahina ang nararamdamang intensity o pagyanig. Tulad halimbawa ng mga nangyayaring lindol sa Luzon. Naitala dito ang pinakamalakas na magnitude na 6.1 at intensity 5 na naging sukat ng lakas nito sa Batangas.
When the earth shakes, the ground moves, and things start to fall, you'll ask yourself, how prepared or unprepared are you? Have you removed objects from over the bed and over your head? Anchored your possessions securely to the wall. It won't be a pain, and you're not doing it in vain. Are your emergency kits packed? What about your family, your friends? Did they know what to do, how to get in touch, and where to meet? Do you know how to drop, cover, and hold on, covering your head and neck? What if you're outside? Or in a car? After the shaking stops, look around. Figure out what to do. Stay away from damaged areas. Turn on a radio. Reach out for help. And if you're trapped, do not move about. Stay calm. Only shout as a last resort. Once everything and everyone is safe, get prepared. An aftershock could be on its way. So before the earth shakes, the ground moves, and things start to fall, get prepared. Make a plan. Practice what you know, because an earthquake can happen anytime, anywhere. You never know.
Ground shaking is the most familiar hazard of an earthquake. It is the result of rapid ground acceleration due to the collision of tectonic plates. Ground shaking is the reason why earthquakes are so dangerous. It is a hazard that triggers this.
Landslides occur when gravity overcomes the frictional forces keeping layers of rock in place on a slope. The ground we stand on is made up of layers of different rock and other materials. Often, a weak geological layer, for example, a fragile layer of shale, will form a failure plane, which makes a slope unstable. The mass of material on top of this plane can be held in place by friction alone. If something happens to disrupt the balance, then the top layer of land can slide away. Heavy rain is a common cause of landslides. The water adds weight to the upper layer, and resulting mud acts as a lubricant. This extra weight and reduced friction can cause the upper layer to slide away. Deforestation can contribute to landslides too. A network of tree roots will hold land in place. But if the trees are removed, the roots rot and the land becomes liable to slip. Earthquakes can also trigger landslides. As the ground shakes, the upper layers of rock can become dislodged. It is possible to support unstable ground by drilling long metal bolts deep into the bedrock to hold the upper layer in place. Some landslides happen extremely slowly, making buildings unstable as the ground beneath them creeps over many years. Another form of rockfall is caused by coastal erosion. As ocean waves collide with cliff rock, they can wear it away over time. When the weight of the resulting overhang overcomes the strength of the rock, it will collapse.
What is liquefaction? Liquefaction is a phenomenon that occurs when loose, saturated, cohesionless soils lose their shear strength and stiffness and behave as quicksand during and after a seismic event. During earthquake shaking, loose silts and sands tend to densify into a tighter configuration. In cases where these soils exist above the water table, this densification results in small volume changes but no loss of bearing capacity or shear strength. However, when loose silts and sands are located below the water table and are saturated, liquefaction can be a concern. Because water is essentially incompressible, any densification of these soils due to a seismic event results in an increase in pressure in the pore water between the soil's grains. When this pore water pressure reaches approximately 60% of the soil's strength, loose silts and sands can lose grain-to-grain contact and liquefy. This phenomenon can have catastrophic effects on both above and below ground structures. Liquefaction can result in bearing capacity failures, lateral spreading, and intolerable settlements for bridges, roadways, and embankments. It can also cause intolerable differential and total settlements, and in some cases, a total loss of bearing capacity for buildings and above-ground structures. Structures constructed in the ground below the water table rely on the weight and strength of the overburdened soils. In seismic zones, liquefaction of near-surface sands causes these air-filled tunnels and utilities to float to the ground surface. Is your project at risk for liquefaction?
Surface faulting. It is surface rupture occurs when movement on a fault deep within the earth breaks through to the surface. But not all earthquakes result in surface rupture. Alam natin na ang earthquake can push and pull the ground, tearing the surface and pushing the ground apart and upward. These are known as surface ruptures. A surface rupture may occur suddenly during an earthquake, or it can happen more slowly, or in other cases, surface ruptures often happen along pre-existing faults, as you can see in the pictures. Okay, since we're done with the hazards associated with earthquakes, now let's move on with the hazards associated with volcanic eruptions. We have here the lava flow, lahar flows, ashfall, landslides, pyroclastic flow, Tepra falls and ballistic projectiles, and also poisonous gases. What is pyroclastic flow? Alam natin noong nangyari sa Mount Pinatubo in 1991, it reached 100 miles per hour. It burns or suffocates anything in its path. Pyroclastic flows are volcanic phenomena. A pyroclastic flow is a high-density mixture of hot, fragmented solids and expanding gases. These heavier-than-air flows race down the sides of a volcano much like an avalanche, reaching speeds greater than 100 kilometers per hour and temperatures between 200 degrees Celsius and 700 degrees Celsius. Pyroclastic flows are considered the most deadly of all volcano hazards. It derived from the Greek pyre, meaning fire, and klastos, meaning broken in pieces. A pyroclastic flow's broken pieces consist of a volcanic glass, crystals, and rocks such as pumice or scoria. These solids have been heated and fragmented by an explosive eruption. If the initial eruption is vertical, the force sends debris into the stratosphere. Since volcanic eruptions are caused by magma, which is a mixture of liquid rock, crystals, and dissolved gas, it expelled onto the Earth's surface. Did you know that Mount Pinatubo is one of the most active volcanoes in the Philippines? Because it erupted in 1991 for the first time in 600 years and caused widespread devastation. Mount Pinatubo is located about 55 miles northwest of Manila and rose to a height of about 4,800 feet prior to its eruption. After 2 months of emissions and small explosions, a series of major explosions began on June 12. Resulting heavy ashfalls left about 100,000 people homeless, forced thousands more to flee the area, and caused 300 deaths. In the weeks after the eruption, hundreds more died as a result of disease in evacuation camps. Itinuturing na isang pinakamalaking delubyo ng mga residente ng Pampanga ang pagsabog o pagputok ng Mount Pinatubo. One of the major hazards associated with volcanic eruptions is what we call the ashfall. It acts as an abrasive or clogs machinery, covers vegetation, irritates lungs and eyes. Volcanic ash is formed during explosive volcanic eruptions. Explosive eruptions occur when gases dissolve in molten rock or magma and expand and escape violently into the air, and also when water is heated by magma and abruptly flashes into steam. The force of the escaping gas violently shatters solid rocks. Expanding gas also shreds magma and blasts it into the air, where it solidifies into fragments of volcanic rock and glass. As the cloud drifts downwind from the erupting volcano, the ash that falls from the cloud typically becomes smaller in size and forms a thinner layer. Ash clouds can travel thousands of miles and some even circle the Earth. Now let's talk about the difference between lahars and lava. One of the greatest volcanic hazards is lahars. Lahars are similar to pyroclastic flow, but contain more water. Lahars form from debris avalanches that contain water from snow and ice, which when released mixes with loose debris to form a lahar. From pyroclastic flows and surges which release water that mixes with debris, or from pyroclastic flows which dilute themselves with river water as they travel downslope. Lahars that contain 20 to 60% sediment are usually very turbulent. Lahars that contain greater than 80% sediment usually flow more smoothly, or yung tinatawag natin na laminar flow. These smooth-flowing lahars usually travel much faster than their turbulent counterparts and can float boulders, cars, buildings, and bridges. It happens during 1992. Now let's talk about lava. Lava is molten rock that flows out of a volcano or volcanic vent. Depending on its composition and temperature, lava can be very fluid or very sticky, or yung tinatawag natin na viscous. Fluid flows are hotter and move the fastest. They can form streams or rivers or spread out across the landscape in lobes. Viscous flows are cooler and travel shorter distances and can sometimes build up into lava domes or plugs. Collapses of flow fronts or domes can form pyroclastic density currents. And lastly is Tepra falls and ballistic projectiles. The term Tepra defines all pieces of all fragments of rock ejected into the air by an erupting volcano. Most Tepra falls back onto the slopes of the volcano, enlarging it. But billions of smaller and lighter pieces less than 2 millimeter diameter, less than 1/10 of an inch, termed ash are carried by winds for thousands of miles. Falling ash, even in low concentrations, can disrupt human activities and hundreds of miles downwind, and drifting clouds of fine ash can endanger jet aircraft thousands of miles away. Aircraft that fly in the dense network of aviation routes across the Cascade Range carry nearly 200,000 people daily.